Here's the answer for day 2, problem 1. A polygon is graphed below. It is translated by the function x plus 1, y plus 3. Translated means it's slid. X plus 1 means that it's slid right one spot. Y plus 3 means that it's slid up 3 spots. So to draw that, we're going to take each corner, move right 1 and up 3. It doesn't matter where you begin. I'm going to start with M. Right 1 and up 3. This new dot is M prime, which means the image of point M. For X, right 1 and up 3. This dot is X prime. Point J, right 1, up 3. Here's J prime. And then point E will move here. This will be E prime. Then connect these together. So this figure in red ink is the image of the original after the translation. There's a part B to this question. What are the coordinates of point E prime? Right in the center of the grid is the origin. Here's E prime. It's left 1 unit, down 1 unit. And so it's -1, comma, -1. Day 2, problem 2. Triangles are drawn below, congruent parts are marked. Are the triangles congruent? This is a yes or no question. If you answer this question yes, then you have to give the postulate as the reason. If you answer the question no, that's because there was no postulate that could be used. There are a couple sides that have little tick marks on them, and that indicates a pair of congruent sides. For instance, if this has a double mark here and on the other triangle there's a double mark, then that's a pair of congruent sides. Now, even though it's not marked, we also know there's a pair of congruent angles. I'm going to put loops in those angles. This angle is congruent to this angle here. They're formed by intersecting lines, so they're vertical angles, and vertical angles are congruent. Is there sufficient information to know the triangles are exactly the same size and shape? Again, the double marks indicate a pair of congruent sides. The triple marks indicate a pair of congruent sides. And the little loop that I made indicates a pair of congruent angles. Take a look at what I've written here. S, A, S, as you move around one of the triangles. SAS is one of the postulates. We're going to answer the question yes. And our reason is the SAS postulate.